So now we'll see some more examples on mensuration. First, note down the example. Then accordingly we'll see how to solve it. A wooden article was made by scooping out a hemisphere from each end of a solid cylinder. If the height of cylinder is of 10 centimeter and its base is of radius 3.5 centimeter and hemisphere is of same radius. Find the total surface area of the solid. So in the question it is given that there is a wooden article and this wooden article is of cylindrical shape and the hemisphere is cut out from each end of this cylinder. That is, there are two ends of the cylinder from which the hemisphere is cut out, and the radius of the hemisphere is same as that of the radius of the base of the cylinder, and the height of cylinder is given as 10 centimeter. So accordingly we need to find out the total surface area of the solid. That is, when we cut down the hemisphere from the cylinder, so what will be the remaining area, what will be the remaining part? We need to find out the total surface area of the remaining part. So first we'll draw the diagram, and accordingly we try to understand what can be done in this. So as it is given that the wooden article is of cylindrical shape, so first we make cylinder, shape of the cylinder, and accordingly it is said that hemisphere is cut down from each end and of same radius. So accordingly the height of the cylinder is given as 10 centimeter and the radius of the cylinder is given as 3.5 centimeter. So now the hemisphere is cut down from each end. So as we cut down the hemisphere from each end and of the same radius, so accordingly the remaining area, we need to find out the total surface area of the remaining part. So first we'll see the curved surface area of the cylinder, because the inner part of the cylinder is cut down but the outer part is remains the same. So first we'll see the what will be the, to find out the total surface area, what we need to do is total surface area, we need to take the curved surface area of cylinder plus we need to take the curved surface area of hemisphere. We need to take curved surface area of the hemisphere in both the hemispheres, so that it means we need to take the twice of the curved surface area of the hemisphere. So how to solve it is, the curved surface area of cylinder, as we know that the curved surface area of the cylinder is 2 pi r into h plus twice of curved surface area of hemisphere, and curved surface area of the hemisphere is 2 pi r square. Now as we see that in this case in both the cases that is in the curved surface area of the hemisphere and cylinder, radius is the same, so that's why we have taken radius as r, that is same in both the cases, and height we have taken as h. Now we'll keep the value of the radius and the height in this, and accordingly we'll find out the total surface area. First thing is as you can see that 2 pi r is common, so first we'll take 2 pi r as common, 2 pi into r, and r is given as 3.5, so we'll write it as 7 by 2. Now in the bracket h will come and the value of h is 10 plus 2 into the remaining part is here is again r only, so it will take 7 by 2. So this thing we have taken common, and the remaining part comes in the bracket. So accordingly now we'll solve it and we'll see what will be the answer for this. So we'll keep the value of pi here, that is 22 by 7 into 7 by 2, and if we solve this bracket part, what we'll get is 10 plus, we cancel out this 2, we'll get 7 here. Now and 7 is 7 cancel out here also, 2 cancel out, so remaining part is 22 into 10 plus 7, that is 17. And if when we find out the value of 22 into 17, we'll get 374 centimeter square. So this is the total surface area of the remaining solid. So accordingly, it is very important first to understand the diagram properly, and accordingly and to see what will be the like in the question it is asked, that is what will be the total surface area. So accordingly we need to see what will be the remaining part, then accordingly we can find out the total surface area. So in this way we have to analyze the question and accordingly solve the question. Now we move on to the next question. First write down the question. The question, it is given that a hemispherical bowl of internal diameter 36 centimeter contains a liquid. This liquid is to be filled in cylindrical bottles of radius 3 centimeter and height 6 centimeter. So how many bottles are required to empty the bowl? So now in the question it is given that there is a hemisphere ball who is filled with a liquid, and the internal diameter of that hemisphere ball is given as 36 centimeter. Then this liquid is now is to be filled in the cylindrical bottles, and radius of that cylindrical bottles is 3 centimeter and height is 6 centimeter. So it is asked that how many bottles are required to actually empty the bowl so that the liquid of the bowl will be transferred totally into these cylindrical bottles. So we need to understand that when it is given that there is a hemispheric ball who is filled with a liquid, and this liquid is getting transferred into the bottles. So it means that the volume of this hemispherical ball is equal to the volume of all the cylindrical bottles that are required to empty the ball. It means volume of both these things should be same, then only the whole liquid of the hemispheric ball will get transferred into the cylindrical bottles. So we need to analyze this thing, that volume of hemispherical ball will be equal to n. Let's say n will be the number of cylindrical bottles required, so it will be equal to n into volume of cylindrical bottles. So volume of one cylindrical bottle multiplied by the total number of bottles will be equal to the volume of the hemispherical bowl. So now we'll see the what will be the volume of cylindrical bottles and bowl. So in the question it is given that the radius of this hemispherical ball is 18 centimeter. The radius of the cylindrical bottles will be given as 3 centimeter, and height of this cylindrical bottles is given as 6 centimeter. So now we'll see what will be the volume or what will be the number, how many number of bottles are required to empty the bowl. First we'll write down the volume of hemispherical ball. So volume of hemispherical ball is 2 by 3 pi r cube. That is the volume of the hemisphere. This will be equal to n into volume of cylindrical bottles. So as we know that the volume of cylinder will be pi r square into h. So now accordingly we keep the value of capital R, small r and h, and accordingly we find out the value of n. So first 2 by 3 into pi into r cube. Capital R is, that is the radius of the hemisphere. So it is equal to 18. So that is 18 cube is equal to n into pi small r. Small r is actually the radius of the cylinder, which is equal to 3. That is 3 square into h, which is equal to 6. So now as pi will get cancelled, so accordingly we solve it. So n will be equal to 2 by 3 into 18 into 18 into 18 divided by 3 into 3 into 6. So this thing will get when we take the part that is with the n. We'll take this part to the LHS side. We'll get this thing. So now accordingly we'll solve it. So 3 6 18. So this 18 will get cancelled according 3 6 18, then 3 6 18. So so remaining part is 2 into 6 into 6. So that will be equal to 72 bottles. It means the value of n is 72. That is 72 bottles are required to empty the liquid of the hemispherical ball into the cylindrical bottles. So now we move on to the next problem. First write down the problem. A well with 10-meter inside diameter is dug 14-meter deep. Earth taken out is spread all around to a width 5 meter to form an embankment. So find the height of embankment. So in the question it is given that the well is there, which is having the inside diameter that is 10-meter, and its dug that is height of that well will be 14-meter deep. So earth that is taken out from the well, when we have dug this well, the earth that is taken out is spread around that well to form a wall or to form an embankment, and width of the embankment is given as 5 meter. So we need to find out the height of the embankment. First we need to analyze that as the well is dug out, so the shape of the dead well will be of cylindrical shape, and the embankment that is formed is also of the cylindrical shape. So it means that this is a well which is in the cylindrical shape, and around it an embankment is formed. So in this way, this is the well, and this is the embankment form, and the height of this well is given as, or it is dug to the depth of 14 meter. This is said, and this radius of this uh, well is given as 5 meter. So now the embankment is formed. This is the embankment formed, and the width of this embankment is also given as 5 meter. So accordingly, we need to find out what will be the height of this embankment. That is, let's take this height of this embankment as small h. So we need to understand that the volume of the well that is dug will be equal to the volume of this embankment formed, because it is the same earth is used to form this embankment. So it means the volume of both these things should be same. So accordingly, we'll take the volume of both these things equal, and accordingly we'll find out what will be the height of the embankment. So the well that is dug, the volume of that we have to take the volume of the cylinder, because the well is in the shape of the cylinder. So the volume of that cylindrical part will be equal to pi r square h. So let's take this as capital R, that is the radius of the well, into capital H, that is height of this well, will be equal to pi. And this again, this embankment is in the form of cylindrical, but it is actually a hollow cylinder. So it means we need to take the volume of this hollow cylinder. So accordingly, the volume of this hollow cylinder is that is the volume of this outer surface. Means first we need to take the radius of this outer surface of this cylinder, and accordingly we need to subtract the uh, uh, volume of the inner part or inner cylinder from this outer cylinder. So accordingly we get the volume of this embankment. So that volume of this outer surface will be or the outer cylinder will be pi r square. In this, now if we when we take this outer cylinder, the radius of this outer cylinder will be 10 meter, because 5 meter is the width of the embankment, and 5 meter is the radius of this inner cylinder. So it means the radius of the outer cylinder is 10 meter. So pi r square, that is 10 square, into h, that is small h, minus pi r square. R, now in this case we need to subtract the volume of the inner cylinder, and inner cylinder radius is 5 meter. So it means 5 pi 5 square into h, that is small h. So now accordingly we need to solve, and we'll find out what will be the value of small h. First we'll cancel out this pi because it is the common part of LHS RHS, so we'll cancel out. Now the value of capital R is 5 meters, so it is, we'll take at 5 square into capital H, that is 14, is equal to, we'll take out this small h common, we'll get 10 square minus 5 square, that is 100 minus 25. So accordingly H is equal to 5 square, that is 25, into 14 divided by 100 minus 25, that is 75. We'll cancel out this 25, 375. So that is 14 by 3 meter, or we can write it as 4.67 meter. So this will be the height of the embankment that is formed when the earth is taken out of the well, which is of depth 14 meter and of radius 5 meter. So accordingly we need to, like, most important thing is we need to analyze the question, or we need to make the proper diagram accordingly, then only we will be able to understand like what is asked in the question and how to find it. And now we'll see one more example on it. Understand, write down the question, that is a vessel in the form inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped in the vessel, 1/4 of the water flows out. So find the number of lead shots dropped in the vessel. So in the question it is given that there is a vessel which is actually in the form of inverted cone, and in this vessel height and radius are given, and this vessel is actually filled with water up to the brim. Now the lead shots are dropped, and the lead shots is of spherical shape, and radius of lead shots are given. So the lead shots is dropped, the 1/4 of the water that is there in the cone, inverted cone, is flows out. So accordingly we need to find out how many lead shots are dropped in the vessel. So we need to understand that as the 1/4 of the volume of the cone flows out, it means that 1/4 water that is comes out will be equal, volume of that part will be equal to the volume of all the lead shots that is dropped in the vessel. So it means that the volume of lead shot, all lead shots, that is, let's say n number of lead shots are there. So volume of n lead shots will be equal to 1/4 of the volume of the cone, because 1/4 of the water flows out. So it means that 1/4 of the water is actually filled with the volume of this lead shots. So we need, so accordingly we need to take the volume of cone will be equal to n into volume of lead shots, and this lead shots is actually in the spherical shape. So volume of cone will be equal to one fourth of the, we need to understand this thing, that we need to take the one fourth of the volume of the cone, because one fourth water only flows out. So one fourth of the volume of the cone, the volume of the cone is 1 by 3 pi r square. R here will be equal to, given as the radius of the cone will be given as 5 centimeters, so pi r square into h, and h is given as 8. This will be equal to n into volume of the lead shots, that is in the spherical shape, so it will be 4 by 3 pi r cube. R is the radius of the spheres, which is equal to 0.5. So that is 4 by 3 pi r cube. And now we will solve it, and accordingly we will find out what will be the value of n. So the things which will get cancelled out, accordingly we will need to cancel that thing. So n will be equal to 5 square, that is 25 into 8 divided by 4 into 4 into 0.5 cube. So 0.5 cube will be equal to 0.125. So we remove the decimal part, we will get 1000 in the numerator. So accordingly we cancel 25 5's this 125, then 5 we get cancel this 1000, so we'll get 200 here. 4 2 8, then accordingly 2 2 4, and this 2 will cancel out this 200, so we'll get 100. So it means the value of the n that we'll get as 100. It means the 100 lead shots are actually dropped in the uh, conical vessel, and accordingly the one fourth of the water flows out. It means the volume of this 100 lead shots will be equal to one fourth of the volume of the cone.